Apologizing again for the loud fan. I will do just that. I will apologize for the loud fan, you know. Where am I? Where's my library? Come on. Okay. Oh, you know what I'm gonna do? Alright. You know what I'm gonna do? Because I am tired of trying to figure this out. So this gonna get its own a library. Yeah man, put it in a different folder. Move to album, create. One. What am I looking at? Oh, you know what? Today hour. Wait there. Let me look at the date. Let me look at the date. Let me look at the date. Okay. Really? Lies. Alright. I made a promise that I would do that and I didn't. Let me apologize, man. Let me apologize. What am I going to call this folder? Oh, you know, say, hey, why not? Why not? That's what I'm gonna call it. Oh crap! There's more though. Nah, there's more of those images. Yo, people who used to set these papers back in the day. Yeah, I think they were trying to create like, you know, some rebel leaders or something, cause yo, those questions are not easy. They're not easy. So why can't I find them? I was just looking at them a while ago and them just disappeared. They were right there. Really? Come on. What? Anyway. Time me a wasting, man. I just wanted to find. Oh, but these are good too. Yeah, some of them are the city and guilds type questions, some of them are the CSEC ones. Alright, I will come back to that. I might. Alright, whatever. I don't look. Really? Oh, actually, that's why I couldn't find them. I couldn't find them because I actually grouped them already. Okay. Yo, what? Hold on, take a look at this. Don't mind it, that's not entirely difficult, but that's still kind of crazy. Like putting that on a multiple choice is wild. Right? So you have two semicircles, right? And then you have to take one and subtract it from the larger one, right? So obviously this little space in here is the one that gets cut out. Yeah man, them never easy. Alright, these not too bad. The difference between squares, dividing 9 over 2 by 16. Alright, come on now, what am I do? I've never, like this, why that look like a band-aid? That looks like a band-aid. I know what it means though, but still, it's kind of crazy. Yeah, them not ever go set papers like this again, I promise you. So if you can do these, then yeah, you'll be ready. You will be ready. You're ready. You're ready for any exam if you can do that. Okay. Really, man? Come on, man. Come on. All right. Yeah. Wow. Okay. Yeah. Almost right back where we left off, right? Yeah. Yeah. So the last thing we did was number 20, which was 3.46 times 10 to the minus 2. Before that was the loan question where I made the mistake of using 3 years instead of 4. I don't know why I thought it was 3. Don't know why. Don't know why. Okay, number 21. That's kind of interesting. So, okay, fine. What is it saying? So it said this so you have that. Now they're saying two things. Them said this. So I'm trying to figure this out. Is this, yeah, this is a -1 and this is a +3. They want to find out the value of P. Alright. Here's what we know. If X is 0, then something comes out to be -1. Okay. So let's figure this one out. If I write this, and I say that is equal to -1 on the condition that this is replaced by 0. So 0 times P will give you 0. 0 minus Q is just minus Q. So if you divide both of them by -1, then Q is just equal to a +1. So we have at least one part of the line, right? So we have Px -1. That would not make sense. And the reason why that makes sense is because you replace this with 0. 0 times P is 0. 0 minus 1, give it this, -1 right here. So that part makes sense. Now the question is, what about f of 1 is equal to 3? So, alright, let me move that now. F of 1 equal to 3? Oh, alright. So this is what that means now. So f of 1 is equal to P times 1 minus 1, and that is equal to 3. So obviously this is P minus 1 equal 3, resulting in P is equal to so the value of P has to be 4. So let's put 4 in place of this. Now, does that work? The answer is yes. Because if I put 1 in here, 1 times 4, 4 minus 1 is 3. I put 0 in here, 0 times that, 0 minus 1, minus 1. Yeah, so this one is fairly straightforward. So the answer for 21 here is C. Right, the options we had was 2, 3, 4, 5. Right? So meaning two, 3, 4, 5. Right? So our answer is going to be C. So this was for number 21. Alright, 22 is one of them questions that look easy, but we have to be very careful. Right? So this is what the question says, right? It said Mark did 2/5 of a job, right? 2/5 of a job, right? Now, let's say Alan did 1/3 of what was left. Now what was left is 3/5. So that means that him did do 1/3 of this. So this is what Alan did. Oh, let me just make sure that so they are asking what is the fraction of the job left undone. So let's make sure that what we have here makes sense. Okay, alright, so this makes sense. So imagine that I want to say the total instead of J, right? But whatever. So the entire job, right? Obviously you have that would be the entire thing. Yeah? So make we do the maths now. When you do this, it means that Alan did, no, sorry, saying the wrong thing. Mark did 2/5. Alan did 1/5. Now if you add 2/5 to 1/5, it leaves you with what? With 3/5. So all we have to know is do this. If you take that away, this account for Mark plus Alan, right? Mark is the 2 over 5. And based on this, Alan is the 1 over 5. If you add this plus that, you get the 3 over 5. Take that from it. What you have left is 2 over 5. So yeah, that's the answer for this. Yeah. And we have to be careful because, you know, they ask us to find specifically 1/3 of the remainder. Yeah? The remainder was 3 over 5. Right? So, it's like you say, 1 minus 2 over 5, which is 5 over 5 minus that. This part is the remainder. When you find 1/3 of the remainder, you end up with 1 over 5. So that's the, you know, that's the tricky part about that. So now we're at what, 23? Where are we now? We're at, oh, this one not too bad. Alright. Each year a vehicle depreciates by 5% of its value at the start of the year. If it was bought at $20,000, what's its value after 2 years? So it starts at $20,000 and it depreciates by 5%, which basically means you're going to take that from 100 and say 95 over 100 is multiplied by this amount. So this is what happens after year 1. Alright, hold on. Why? There we go. That more I see. Alright. So, okay. So do this. $95 times 2 is what? 190. Okay. So therefore, so this is what it falls to after 1 year. Now, instead of going at the 20,000, remember the 20 got reduced to this, so we'll have to do 5% of this. So what was 95% of this? So the second year now will be 95% of this number up here. So alright, so let me make my life easy now. I'm gonna say 95 times 20 minus 1. Alright, let's do this. Imagine it as 19, but 19 is 20 minus 1. Okay. 190 times 10 is 1900. So we're going to minus 95 from that. So let's see now. 5 here, add a 1, 0. Put a 1, 9 minus 1. There we go. Right? Now, if that's the result, of 95 times 19, multiply that by 10, the result is 1805 and a 0 at the end. So at the end of the first year, it will look like this. At the end of the second year, it will look like that. Yeah. Yo, I go tell you what is ironic. I used to hate all of this, okay? So, I know exactly what you mean. I used to hate, see, every time I did multiple choice and I saw consumer arithmetic, yeah, man, I was guaranteed not to get those questions correct, right? But yeah, if you look now, number 23, based on what we just did a while ago, yeah, the answer is C. What you know? See there? More of the things I don't like doing. Oh God. Alright. An imported item was bought for $150, then subject to a purchase tax, 20% of its cost, and a customs duty that was 50% of its cost. Father God. You might as well not bother buy nothing. Don't bring it to your homeland. Right? Wherever it is, just make it stay there. Cause customs them not play fair. They don't play fair. Don't it? Yeah, man. Listen, man. Honestly, right now it's like you buy a vehicle just for the AC. Alright, what I'm saying? Alright, so this was 150, right? Now them say there's two parts. Them say the purchase, them have a purchase tax. And the purchase tax is mostly 20%. And the father, like this customs, what do you call it? Customs duty. No, sir, this rough. Like that's very rough. Right? So remember, you know, this is that percentage of that. Of this. When you find those figures, you must then add them to this. Now, brother. No. Alright, let's do it. 50% of the 150. See it there? $75. You're already a ball, right? So this is the customs duty, right? You are paying that in customs duty. Then now you have the purchase tax now, right? How the purchase tax go? The purchase tax look like, let me see what that number looking like now. 20 over 100 of the 150. So let's do that. 2 times 15. That is looking like 30. Right? But a ball still. I'm not lying, but a ball. Because after that now, you must now add all of this to 150. Now, my friend, this is very rough. This is very rough. So, you have a 5 here. You have a 15 here. In our real life? Nah, fam. This is too rough. I'm not that rough, man. Remember, you know, and I like say them take it off, you know, they're adding it on. You know? Yeah. So yeah, the answer is A based on this. Based on that. Yeah. And that was a lot of fun. That was fun. Alright, this now, I don't even feel like I want to draw back over that. What is this saying? In the diagram or in the above diagram not drawn to scale, POR, the diameter of a circle, center O and QT is the tangent. Okay, RQT is 46 degrees, right? What is the angle of ORQ? Come on, man. Look here. First things first. Look at ORQ. ORQ have to be an isosceles triangle. So OQR and ORQ have the same, you know what I mean? The same. It's the same. Now, OQ is tangent. In other words, it's not even tangential. I want to say OQ is perpendicular. Oh, yeah, man, don't worry yourself. I'm stressed out too. So look at this. So O to Q is so basically because it's perpendicular to this tangent, that look like a 90 degree, right? So if you add some unknown to 46, make it equal to 90, subtract 46 from the 90, right? That leave you with 44. If this portion is 44, that other portion is 44. Because, yeah, it's going to be 44. Right? Because that's an isosceles triangle right there. Yeah, just looking at it. So, yeah, we're not even gonna waste time right there. So, right? ORQ is the same as OQR, and if you get OQR, you get ORQ. Right? This here is equal to that up there. So, yeah. Not a time I waste, honestly. No, 26 now. That this look, it looks kind of crazy. But if you know it as a fraction, then this will make a little bit more sense. So, alright. So here's what I mean by that. 0.01. Raise that to the 3. But what is this? You went back 2 times. So it's really 1 over 100. Therefore, this is what you actually have. So what you really have is this. In reality, what you have is 1 over a million. You just have 1 over a million. Yeah, 1 over a million. If you raise 1 to the 3, you get 1. This is 100, which is what? 10 to the 2. 2 times 3 is 6. 10 to the 6 is a million. So therefore, yeah. So your answer is 1 over 1 million. So look at this now. you can tell which one is correct. A and B don't make no sense. So we're not even going to waste time with that. A and B have 3 at the end. That don't make no sense at all. So now, yeah, you would just jump back 6 times. That's all that would really happen. Okay? You jump back 6 times. So, even if we're never sure, you know, you put your 1 here. 1, 2, 3, 4, 5, 6. And then all you do, you put the zeros. You put the zeros here, right? So you have a 0 there, a 0 there, a 0 there. So how many zeros we need to have? We need to have a 0 in front of the point. 1, 2, 3, 4, 5 of the zeros in front of 1. So based on that, yeah, the answer is looking like D. Yeah. Now, let me see what this thing is saying. The diameter of a circle with a circumference of 132 centimeters. Oh, okay. Okay, alright. Now, when it comes to the circumference, now this is number 27. I kind of skipped over a lot. Alright, so we're at 27. So there are 2 ways to look at the circumference. 2 ways. The way that I remember it is always this. But another way to look at it too is this is the same as the diameter, right? So that's another way of looking at that. Now, that means that if we want to find out the diameter for this question, I mean, what I would do is put this on this side. So we have pi times d equals c. We divide both sides by pi. So you divide this by pi. You divide this by pi. So all we have to do now is just divide 132 by 22 over 7. So therefore, just so we're making sense, that's what your pi is, and your 132 centimeters is actually that right there. Okay, I'm starting to see something here. So we have to do this and flip that upside down. And something looks familiar. Let's see, 22 times 6, what does that give us? Figured. Yep, that figures. So therefore, if I divide 22 by 22, I get 1 right here. If I divide this by 22, oh, yeah, sorry. Don't know why that faded. So 6 times 7. Alright, whatever. Let me just make it. Let me just put it in black. So 6 times 7. So our answer for our diameter, that is going to be 42 in centimeters. So the real question is, does that work? Does that actually work? If we multiplied 42 by 22 over 7, we'd end up with, yep, yeah, it worked out. yeah, it worked right out. Yeah, so our answer for number 27, according to what we have here, is going to be D. Alright, so 26 was D and 27 was D. Alright. Alright, now for 28. What did they do here? Alright, let me read this carefully. Okay, you know what I love about these questions? You see all of this reading that we're doing, it not helping us with nothing. It's just describing what we're looking at. There's no clue, there's no hint, there's nothing there. They're just telling us what we're looking at. Right? PQRS is a rectangle. I know this. Here it is, PQRS. Thanks for the help. You know. Yeah. Then with E, a point on SR. Oh, yeah, I can see that. Yeah, this kind of feel like when you're watching the jokes never get old. You're watching Hunter x Hunter and they start narrating what you're looking at. Given that what EQ is 5 meters, which is right there, the area of what rectangle though? Oh, do you want the area of the whole rectangle? Alright, that's alright. I kind of see what they did here. Okay, watch this. I'm gonna draw it. I'm actually going to draw it so that it makes sense, right? So we're looking at number 28. Looking at number 28. Hold on. Let me change that number right there. Alright, whatever. Let me just do that. So we're at number 28. We have a rectangle. And something that looks like a right, you know what, whatever, I'll figure that out. So maybe what we'll do is this. What we'll do is this. What we'll do. Oh, yeah. Alright, cool. Now mind you, yeah, mine's a little crooked. Alright, so we go. Really? Come on, man. Alright, something like that. Now it's not drawn to scale, so you know. Yeah, let's bear that in mind. So we have a S here, an R here, a P here, and a Q here. Right? Let me see if I can find a better blue. This here is 3 meters from here to here. And then from here to here, I believe this is 6 meters. And then from here to here, because they don't tell you, but you have to, you know, use your judgment and realize that when they say 5 meters, they're talking about that line right there. Right? Now here's what's interesting. They want the area of the whole rectangle. Yeah? That's what they want. Now, normally what you do is, if they wanted the area of this, you find the area of this triangle and this one, add them together and subtract it from the area of the rectangle itself. Now, naturally, 6 plus 3 means that P to Q is 9 meters. So S to R is also 9 meters. Therefore, SP must be equal to RQ. However, this is what? A right angle triangle. And because of that, we can use Pythagoras, right? So, oh, right, there's E. Yeah, this is the point, E. Alright, whatever. So, what we have is, we're going to say EQ squared is equal to ER squared plus RQ squared. So let me remember to put the point E somewhere about here. Right? That's where E is. Now I didn't have to do that, but you know, I just wanted to label them so that I knew what was what. Now we want there. I'm going to be obvious, right? We have the length of our rectangle already. The length is 9 meters. The width is what we do not have. We don't have the width as yet, right? So we are going to try and find the width. The question is how we're going to do that. Well, we don't even have a length for this side. So it's not like we could use Pythagoras over here. We have 2 missing sides, so we can't have a look at this. Right? So it don't even make sense to waste time over here. But we have 2 sides here. So, change the subject of the formula, minus ER squared from both sides. So therefore, RQ squared is equal to hold on there. Make sure that, yeah. So now, ER is 3. So let's just put 3 in place of ER. AQ is 5. Now that means we'll have 25 minus 9. So we have 25 minus 9. 25 minus 5, 9 minus 5, we have 20 minus 4. 20 minus 4 is 16. So let's just write 16 instead of that. So here we go. We have 16. And now we're going to square root the left and square root the right. That's what we're going to do. So now the RQ finally we get it as 4 meters. So now we can actually put that right here. So the area of the rectangle now is going to be 9 times 4. So the area of the whole rectangle now is going to be so yeah, sometimes they, you know, they want us to go down a bit of, you know, they want us to travel for a bit. Alright, so we're done with that part, right? So we're at 21 to 28. Alright, let's look at we're going 29 to 35. Yeah, I'll probably just stop at the 35. So let's see. What is? Oh! Yeah, this is one of those what is this now? Tom works at an hourly rate of $12, receives 1.5 times his rate in a 40-hour week. What will Alan receive? Okay. Yeah, so I mean, we have to figure out what the, because you have the basic wage and you have the overtime wage. Right? So you have those two. So, oh, what? Why did I think I had the black marker in my hand a while ago? Alright, so Let me just write it. Obviously this term is a little vague because it's really the number of hours when they call it the basic week or whatever. We're not stressing, right? So if you're paid at an hourly rate of that, oh, okay, see? All right, so let's be simple about it. If we were just working off of, all right, I forgot. See, that's why I like using units. Because when you use the units now, you have a better idea of what's going on. If you're paid at $12 per hour and you worked 40 hours for the week, what your basic wage was, H is cancelled, leaving you with right, so that's the basic wage. Alright, so that is 480. Now obviously you have the overtime, right? And the overtime is weird because you have to account for how many times over, meaning how many hours over that. So meaning if you normally work 40 and you work 45, then your overtime week would be considered as 5, right? So that's pretty much how that would work. So let me see what they give us. They say Tom works at hourly rate of 12. We got that. Receives 1.5 times. Okay, so yeah. So the only problem I have though, fine, obviously we're still using this, so we're going to replace this with 12. If we multiply 12 by 1.5, we're multiplying that by what? By 3/2. So this would be So this should be 80. Yeah, the problem that I'm having now is that, I mean, there's very little information to go off. Because if you are told how many hours he worked extra, then you could multiply that amount by this. Whatever that number is, you add it to the 480. So, based on this, them basically put in the overtime argument to waste your time. Because there's not even any reason to use this. You never get the overtime week or whatever. They would have to have said that you worked 5 hours extra or something like that. So if it was something to the effect of you worked 5 hours extra, 5 times 80 would have been 90, you add the 90 to that. So based on the limited information I give you, this would have to be an answer. being paid 1.5 times, it don't mean anything. Because the only time that matters is when you're talking about overtime wage. You can't just be paid 1.5 times and then we don't know how many hours over that you worked. Unless the 40 is the total of the overtime and the basic. It could have been something like that. But again, we don't have enough information there. Just don't. You have the hourly rate. They tell you about 1.5 times. They don't tell you how many hours you worked overtime. No. So yeah, the answer is just A. The answer is literally just A. Like they literally put that there to waste your time. So that's really a trick question. Yeah. you don't need this whole 1.5 times don't mean anything. Because guess what? They never told you what the overtime hours were. They never tell you, you can't use it. So all of this, just forget about it. Yeah, that's it. The answer is A. So yeah, we're not wasting no more time with that. Unless they told you how many hours overtime, like they said, oh, you worked 1 hour, 2 hours, 3 hours over the time. Sure. But nah, not with the information they give us. Oh, look at this. The HCF of this set of numbers. Now, this is interesting. So, this is number 30. Wait, sorry. So, we have 54, 72, 90, and 108. Okay, let's see what let's see what happens. 54, 72, 90, 108. So this is 27 times 2. This is 9 times 8. This is, and then this is 54 plus 54. Therefore, you multiply 2 times that. So now we have to find the HCF of all of this. Oh wow, hold on. You have to be extra careful with this one. You have to be, watch this. You have 2 by 3 by 3. You have 2 by 3 by 3. You have 2 by 3 by 3. And you also have 2 by 3 by 3. You would have looked at this and thought that because they're multiples of 9, the HCF is going to be 9. But in fact, the HCF of them is 18. Yeah, that probably would have catch me too. So therefore the answer is going to be B. Yeah. So there's that. Alright. 31 is one of them ones as well. In the diagram, X and Y are points on the circumference. Da 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 da. Alright. Okay. So you have the length of the minor arc, which is pretty much a fraction of the circumference, right? So that's what this means. So let's look at this now. We have, so our normal circumference is this. However, the length of our arc is really something to that effect. I mean, if we want to call it L or whatever, length of major or minor arc, that's what we want to call it. So based on the diagram that we have, let us say they gave us this. The middle here was 80 degrees. They're saying that this is X here, this is Y here. They want to know the length of this line. Therefore, this 80 needs to go up here. So we'll have 80 over 360, resulting in 8 over 36. Now, here's the thing that's interesting though. They said that the circumference is what? The circumference is 7.2 centimeters. Therefore, we can replace all of this right here. Not bother waste any more time. So let's move that a little bit. If I'm reducing that to its lowest terms, then naturally that becomes 2 over 9. That's 2 over 9. $72 over 9 is 8. So 7.2 over 9 is 0.8. Therefore, there we go. So our answer for this is going to be yeah, 1.6. Yeah. So that's the answer for number 31. And then 32 is one of them worded questions now. The length of a rectangle is half and its width doubled. Alright, so let's try and make sense of that. You have a normal rectangle L and W. So oh, hold on, sorry about this. Okay, where was I now? The length is halved, so I guess you can call this half L. And the width is doubled. So what exactly happens to that? Multiply them. 2 times 1 over 2 is 1. L times W is LW. The area of both of them will be LW. Therefore, it remains the same. Yeah. So, this is the answer for 31. And for 32, I mean, both of them will remain as LW. This is LW. That is LW. They will remain the same. Because even if you're never sure, 2 times 1 over 2, 1. L times W, LW. Nothing changed, really. Nothing really changed. I mean, all you really did was take this and just put it sideways. That's basically what you did. So, yeah. Alright, this one is interesting because then put some larger numbers just to make it look a little intimidating. This is number 33. Look at this. Right angle triangle, then put it upside down just to see if we're going to get frightened, right? And then put some larger numbers, right? So look at what they did. Then put 60 right here, 80 right here, and 100 right here. Now do the maths. Divide everything by 10, that's 6, 8, 10. You know, I mean, this part is 6. This part is 8. This part is 10. All we did with that is multiply this by 10 to get all of that. So that's virtually what this is. Now they're asking, wait there, this is S, this is T, this is R. They want to know what the sign of TSR really is. That means they want this. In order for this to make sense, we'd have to draw the triangle different. So we'd have to do some sort of rotation of it. So if that's the case, T would be down here, R would be up here, S would be down here, that would be the angle. Distance between T and S would be 60. This would be 100 for sure, but that's the longest side. Over here must be the 80. So you have to redraw that. Okay. Now that we have that, there's a question now. This is the vertically opposite, don't it? Thus it is called the O. The longest side is naturally H. So, going by SOHCAHTOA, you would say it would be the sine of O over H, which is the sine of, what is this now? The O is 80. And the H is 100. Reduce it to its lowest term now. What is 8 over 10? So just by looking at that, what you would have is a sine of 4 over 5. Right? So 80 over 100 reduce all the way down. The sine of it would be, well, the sine of the angle would be equal to. So let me be more precise. The sine of the angle so let me just right. So the sine of the angle is equal to 4 divided by 5. Yeah. So the inverse of that would give us what the size of the angle is. So our angle will depend on, that's going to be B. Right, so 33. Yeah, the answer is B. Alright, so let's see now. MPQ is a semicircle attached to the side of a rectangle. That makes sense. MR is equal to 15. RQ is equal to 28. Oh, okay. Oh, I want to know the perimeter. Okay. Okay, that's actually interesting. So MR would be the diameter, so half of that would be okay. Just so we know what we're talking about, we're looking at that. So what would happen is, I mean, you're kind of drawing like some dotted line from N to Q right here. Right? But fine, let's do that. Seeing that we're done with all of this madness up here. So, yeah. Alright. So let me just draw it. I will say we want it to be a little bit more. Yeah. As close to realistic as possible. There's a P here, N here, Q here. Alright. M here, R here. So this would be 14. Here to here is 28. Okay, Now, they want the perimeter of the whole thing. So far we have 3 parts of that. So far we have this. So far we have this. And we have this. We have this. So we have this part. There's only one part left. That part that we need is this line right here. So let me change it to blue so that we can see. Right? My P disappeared. Alright, good. So we need the length of that line. Now watch a joke. It's a semicircle. So that's your measurement automatically. That means your 180 over 360 already makes it half of whatever the full circumference of that thing would have been. Right? Your circumference would have been 2 pi r or pi d. I mean, pi d make it easier. So pi times the diameter. Question is, what is the diameter? Well, this line is equal to that line, and that line would have counted as the diameter. If MR is equal to 14, NQ is equal to 14. Therefore, your diameter is going to be this 14 right here. Now, your pi would be more than likely 22 over 7. So, divide this and that by 7. A 2 up here, a 1 down here. So therefore, the length of that will be what? 22 meters. Right? So now we have the length of our arc, thus giving us the length of this line, which is 22. We add 22 to all of these. So 22 plus the 28 will be what? That will be 50. So yeah, your perimeter would be that combination right there. So 50 plus 28 is 78 plus this. Yep, that looks like 92. So our answer for 34 is going to be A. So yeah. Okay. So now we're on to 35, 35. Yeah, this is a weird one because we have to depend on this to create the diameter for that. This is a semicircle which is half of a full circle, and so because of that we needed the length of the arc, because if you try to focus on finding the area, that not will make any sense. So here's that. So now we're on to number 35. How that one go again? Oh, alright, so the simple interest was 108. That's the trick to this question here. So therefore your I is actually 108 and not this. This is actually your original. So therefore this is your and this is your interest. Now with that in mind, this over here has to be your that has to be a time. So and the equation that we know it to be is what? Now they're asking for the rate because we do not have the rate. Multiply both sides by 100. And then what? Divide this by PT. If you get comfortable with doing that, then you don't have to guess. So now what you really have is 100 times I over P times T. So now we will just substitute that which you see. So this will be, so this will be 108. This will be 3. And at 1600, cross out the zeros. Well, if I divide 108 by 3, 0 there, 3 is 9, put on 118 is, alright. So therefore, so your answer is ultimately 36 divided by 16. Ah, okay. So 9 divided by 4. Okay. 9 over 4. So 36 over 16 resulting in so if you reduce that, yeah. So now let us see. So I have 4 over 9, 2 1/4, 5 and 8. And what we have here is 2 1/4 there. Yeah. So we left off at the number 35. Yeah, that one, you just have to be careful. Because, yes, you can divide your 36 by 16. You could have do it. But ultimately, you end up with 9 over 4. Change 9 over 4 into 2 1/4. And that's it. That is it. Now I'd love to go on to the rest. Right? Eh? Oh. Okay, yeah. Yeah. So whenever I hop on again, then yeah, I'm going to continue from 36 going forward. So that will be all for now. Thanks for helping me to stay consistent. As I always tell you, honor your commitments. And of course, my favorite line: die when it's time to die. Discipline is everything when it's time to do it every time. So there you go. Yeah, that does it for now.